Recurring decimals to fraction is a sure-to-come math topic and it is often repeated in a non-calculator paper. Here is a lesson explaining it. Fractions, decimals, and percentages are frequently used in everyday life, and knowing how to convert between them improves general number work and problem-solving skills. Converting recurring decimals to fraction is one such topic for GCSE exam. It's a sure topic to appear in exams, especially for your non-calculator paper. Alright, let's look at some examples. A recurring decimal exists when a decimal number repeats forever. For example, 0.3 recurring. Dot notation is used in recurring decimals. The dot above the number shows which number reoccur. So this is 0.333 and so on. And the decimal will never end. Another example is 0.87. In here, the dot is on top of 7. So this is 0.87777 and so on. Say if you have 0.37 and this time the dots are on top of both numbers, and this is equal to 0.37373737 so on. Now sometimes two dots can be used. They show the beginning and the end of the recurring group of numbers. For example, 0.412. The dots are on top of 4 and 2. So this is equal to 0.412, 412, 412 and so on. So now we will look at how to convert these recurring decimals to fractions. A typical exam question will look like this. Prove algebraically that the recurring decimal 0.47, where 7 is recurring, can be written as 43 over 90. We gotta prove this algebraically. You can try to divide 43 over 90 and see if that will match the recurring decimal 0.4777. But that's not the approach we have to do here. We need to prove this algebraically. So watch this method. First we equate the given recurring decimals to x. So we have x equal to 0.47, where 7 is recurring. If that is so, then 10x would be 4.7 recurring. If x is equal to 0.47, then 10x would be equal to 4.7 recurring. Then 100x would be 47.7 recurring. You can keep going if you want to 1000x, 10,000x. But we will stop as soon as we have a set of numbers which are same after the decimal point. For example, in here 10x equal to 4.7 recurring. The number after the decimal is recurring 7 only. And in case of 100x equal to 47.7 recurring, the number after the decimal is recurring 7 only. When you get two sets with the same digit recurring after the decimal, then you can stop multiplying. The next step is to subtract those two sets. So it will be 100x equal to 47.7 recurring minus 10x.47 recurring. Notice that both numbers 47.7 recurring and 4.7 recurring both got the same decimals, and therefore when you subtract this, this will become a whole number. Let's subtract and see. 100x minus 10x, that's equal to 90x. 47.7 minus 4.7 will be 43. And here we have a linear equation in one variable, and the variable is x. So all you now need to do is make x the subject. So x is equal to 43 over 90. Initially we stated x is equal to 0.47 recurring. Now we worked out a fractional value for x, which is x equal to 43 over 90. That means 0.47 recurring is equal to 43 over 90. That's all, guys. The recurring decimal is now written in a fractional form. So step 1, equate the decimal to x. Step 2, keep multiplying the equation with tens until you get the same numbers after the decimal. Step 3, subtract two sets that have the same digits after the decimal. Then we have step 4, solve for x to work out the fraction. And finally, step 5, simplify that fraction if possible. Please pause this lesson now and go through the steps. Alright, let's look at another example. Please grab a pen and paper, try this question yourself. Once you're finished, Play the video and check if you have got it right. So pause this lesson once again and try this question yourself. The question reads, prove algebraically that the recurring decimal 0.681 reoccurring can be written as 15/22. So firstly, equate the decimal to x, and that's x is equal to 0.681 reoccurring. If that's so, 10x will be equal to 6.81 reoccurring. 100x is equal to 68.181 reoccurring. Until now, we don't have a set with the same numbers after the decimal, so we will continue. Then 1000x is equal to 681.81 reoccurring. And there we go, guys. Now we have 10x and 1000x pair with the same digits after the decimal, which is 81 reoccurring. Next, we will take these pairs and subtract them. So that will be 1000x equal to 681.81 reoccurring minus 10x equal to 6.81 reoccurring. 1000x minus 10x is 990x equal to 881.81 reoccurring. Take away 6.81 reoccurring will be 675. And now we will solve for x. So x is equal to 675 over 990. This fraction here is not simplified. You can see it can be simplified with 5. So this is equal to 15/22. Here is something that you can do. You see the fraction 675 over 990. If you're confident at your working out, then you can simply write this as 15/22. So this means 0.681 recurring decimal is equal to 15/22. Alright, this is quite an important and a sure to come up topic for exam. Make sure you do practice such questions, but that's all for this lesson, guys. Take care.